Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Today on the bench I have a NAD stereo integrated amplifier. This is a C326BEE, and this came to me. I picked this up on local buy and sell Kijiji. A very nice, attractive price. Has a fault, and I'll explain here in a moment. But I was looking at this. I've had it for a while now, and I've been using it. It came with the box. It came with the book, a big thick book here, and how many different languages? 7, 8 different languages. It comes with a remote, so it's all equipped. And this thing, I believe, has lived its life inside a cabinet. Judging from how pristine it is, it doesn't look like anybody's ever touched the controls aside from me. I've been using this for the last 3 or 4 weeks now. And just to confirm what's going on. Maybe a little scratch there, maybe that's all there is. So this thing has a mind of its own. It shuts off. That was the complaint to the previous owner. It shuts off at random times. And I've confirmed, yeah, it does do that. Not very often though, because when I first hooked it up, it did it for probably the first week or so. It would do random things. What it was doing, it was shutting itself off, going into standby. And now, first you'd think that would be, oh, it's going into protect mode, but no, it wasn't doing that. Reason being is it wouldn't always shut off, but it would glitch and it would do different things. For example, if I was listening on auxiliary, sometimes it would glitch and the tone defeat would come on, and sometimes it would glitch and it would go to media player. And sometimes it would glitch and shut itself off. So that doesn't tell me it's an overload situation on an amplifier or anything like that. What it tells me is we got dirty power in the power supply, and that's probably the cause of our grief here. So I have a feeling we're probably looking at bad caps again in the power supply. And so let's go through this and we'll see if we can get this running good again. Now, the first week I used it, it was doing this random glitching thing, and it wasn't doing it very often, maybe once a day. And then after I listened to it for a few more weeks, it stopped doing it and it started behaving again. So like I said, I think it's capacitors, because once the capacitors got a little bit of use behind them, they started to smarten up again. But yeah, it's definitely annoying, because you're listening to program source and then it decides to turn the tone defeat on, and when it glitches on, it mutes the sound for like a second, and then when it switches from auxiliary to media player, it mutes the sound for about a second as it switches over. And you can see this happening with the lights. So let's get into it. Let's look at it first. Power button, soft power button. It's got a remote input here. It's got a little window, and it has input for media player and a 3.5mm jack stereo input, as well as a headphone output here. A soft clipping button. It's got media player, CD, tuner, disc, auxiliary, video, one tape monitor input, and a tone defeat, and bass, treble, balance, and volume. Pretty sparse. But actually, it's a great sounding amplifier. The time I did use it, I liked it. On the back, we got inputs for media player as well as the front. CD, tuner, disc player, auxiliary, video, and then we have our one tape loop, our subwoofer outputs, our preamplifier outputs, main amplifier inputs, which is good. We can separate those. One set of speakers, no switching. Soft clipping, we have the option to turn it on or off, and we have a remote for triggering something else, a 12-volt trigger, and we have infrared pass-through on the in and out here. So this is for the remote. Extended power switch here, so if you go away for a vacation, you can shut it off and it's not consuming power, and it's not in standby mode. And then we have an IEC connector for our power input, which is nice. A few other things I noticed. Somebody's been in here. The screws are a little damaged on the lid, and we got a warranty sticker missing here. This one's intact. We have a couple one warranty sticker missing here. This one's been opened. There's a intact warranty sticker here, and I think there's another one somewhere too. Oh, maybe that's it. There's 1, 2, 3, 4, 5 stickers, warranty stickers on this. I guess they were determined not to. They didn't want people getting into it. So let's pull the lid off and we'll have a look inside. Alright, here's a look on the underside. Not much to look at. Some heavy duty wiring here. Passing some heavy current for the amplifiers. Not much else to talk about here. I'll look around and I'll see. I don't see any, right off the bat, I don't see any cracked solders. And but that doesn't mean there isn't any. So I don't see any bad heat scorching either. Maybe here and here a little bit. It seems like about the only spot. But overall, it's fairly good condition. I'm going to what I'm going to do, I think first, is pull out this power supply board so I can get a good look at the capacitors in it. Seems like everything unplugs here except for one connector. Got a couple zip ties. I should be able to get that all out. Alright, so I removed the power supply board and I checked out this little switching circuit here. There's a little switcher. There's a main primary circuit main filter cap that's 10 microfarad at 400 volts. That cap is fine. And then it goes, this is the control chip, the bridge control chip, the transformer, the main filter cap, and then from here it goes to this diode, this big fat diode here, and it goes across to here. And there's a couple of 330s, 330 at 10 volts. I pulled these out, tested them, they are fine. So everything in this circuit is working normally. And this is the standby circuit when the machine's in standby mode. Now, I don't know if this is the problem. I don't think it is because everything's checking out here. It seems we might have a glitch on one of the logic power supplies. So this is a plus 5 volt regulator right here. And you can see it's a 7805. Now, if this regulator is faulty, it could glitch out. Also, I'm going to take the front panel apart and I'm going to check the caps in there as well, because if we're getting glitching, what I might do is just scope this, scope the output of this. They have a weird setup where this regulator is fed by 37 volts. It's a 5 volt regulator, so they have to drop it to 22 volts. And no, actually 32 volts, my mistake. So what they do is they have a regular silicon diode, and then they have two Zener diodes, 5.1 volts in series. They're 3 watt Zeners, and that drops the incoming voltage by 10.2. So that drops it down to the range where this is happy. But that could be also failing as well. I don't see where these diodes are. I don't see them on here. They could be back on this. They could be back on this board. Could even be, let's see here. 3 watt Zeners are pretty big. I don't know, I'm going to have a look around. But I'm done with this board. I'm going to put it back. And like I said, maybe I'll hook a scope up and I'll check this regulator. But it's not glitching now. After being used for a few weeks, it hasn't glitched. So I'm wondering how I'm going to find this fault. So the more I look at this amplifier, the more I realize I'm not the first one to attempt to repair this one. This power supply board, the screws were loose and the seals were broken on them. They have glue on each screw and they were all broken. And somebody's had this board out. And somebody's been in here too, because they added a capacitor here. This is not factory. They tacked it in here in that circuit, hoping to cure whatever problem it is. And then we see we have a capacitor on the other side. Maybe they were trying to strengthen that filtering. And then they have pin marks on all the screws and marks on connectors. Yeah, so this has all been worked on before. I don't know if they were successful or if they gave up, and maybe I bought a lemon. Well, I know I bought a lemon. That's no question about that, but maybe they put their effort into it and gave up. But we'll see if we can find it. I still suspect this 5-volt regulator to be defective. I'm going to get this, I'm going to check out all these capacitors here on this main board. There's quite a few of them all along here, and if they're all good, I'm going to connect this all up and then we're going to scope this plus 5-volt line here and see what kind of mischief it's getting up to. Okay, so here's just an example of what I just pulled out of the amplifier. This is out of the audio amplifier power amp, and this is 100 microfarad at 50 volts. ESR should be down around 0.3 and we're up at around 1.2. So this one's going to get replaced. Now I'm poking around here checking a few caps and I don't see terribly anything wrong, not like you usually do on these NADs. But I'm going to go through and I'm going to replace the worst ones, and it probably might be 5 or 10 capacitors. Who knows? It's not going to be that many. But I'm going to do that now before I go any farther. Now that's not going to fix our problem. That's just going to be preventing future problems. So I'll go through and do that now. I'm still thinking that voltage regulator is bad, so I'm going to get this, whatever needs recapping here, I'm going to recap and put it back together, and then we can start testing. Okay, so I've been doing a little bit of work here, changing caps mostly, not too many. I replaced these two. I replaced these two and these two. I replaced these 4, and then I replaced these 3. Only because they had high ESR. The rest of them I tested, they're okay, I guess. I'll leave them alone. But I'm not going to change all the caps, because a lot of these 10 microfarad at 50 volt, they're all good. I'm just going to leave them alone. So I just want to make sure there's no glaring things wrong with this amplifier. So what I've done is I put it all back together. I took the front panel board off and I checked the PC board for this. Didn't see anything wrong. Couldn't find anything wrong. I did see that there was... Oh, hang on. So I did check the front PCB board and I opened it up, had a look at it. I couldn't find anything wrong. I did notice that there was a previous tech in here before me changing caps. I changed 3 capacitors. So I think, I have a feeling I'm not the second one with this hot potato in my hands. I think somebody else had a kick at this to try and repair it, and I don't think they were successful. Or maybe they were successful and maybe it came back. I don't know. But we're going to determine to see if we can figure this one out. So got it all back together. Got to plug a few more cables in and then we'll be done. I'll plug all these back in. And what I'm going to do is I'm going to power it up. I tapped a line off the 5-volt regulator and I got it attached to my electronic load, and I'm going to start applying a load to this regulator to see if it's glitching or if it's dropping out. I also got a voltmeter tested across it. I could probably even put a scope too. I'll put a scope instead of a voltmeter. That way I can tell to see if there's any glitching. Alright, so what I did is I attached a load to the 5-volt regulator that is here. And I was able to increase the drain on this this little chip here up to about 1 amp before it kicked off. I suspected it got overheated. Heat seems to be a problem for this thing. Just letting it sit on idle for a number of minutes, like half an hour or so. These 4 heat sinks, they'll get up to 60 degrees Celsius, and these 4 will get up to about 45 degrees Celsius or so. They get quite hot. This little 5-volt regulator gets up to about 60 degrees too, and it gets quite warm. It's uncomfortable to keep your hands on it. So I'm thinking that's normal for this amplifier. I know NADs, they like to run their equipment hot with high current. What I did is I did a little bit of research online on the Google University there, and several people were talking about this specific amplifier. They were having troubles with going into protection mode and shutting down. And what it is, what it turns out to be, it actually is noise coming in on the power line, and it's glitching the microprocessor. So what a solution for they were saying a solution for this is to add a capacitor to the back of the microprocessor board, which I can see somebody's already done. They've been in here and they've done that already. It might have improved the situation, but it didn't eliminate it. We do have the line in, and it goes here, and there is a 250 nanofarad capacitor across the line there. I did not check it. I should actually pull that cap out and check it, because they do, these X-rated safety caps, they do go high in value, or low in value actually. I was looking at the schematic, and this choke is mostly to clean up the hash that comes from this little switcher. Let's go have a look at the schematics and see what we can figure out. Just going to leave this on. Hopefully it glitches. Alright, first up, here's this little 5-volt voltage regulator. It has 37 volts coming in, if you can believe that. And it goes through a 1N4007 diode. And I don't understand the purpose of this diode. It doesn't... Well, what its purpose is it drops the voltage by 0.6 of a volt, and then it passes through 2 Zener diodes, D135, D134, and they're 5.1 volt Zener diodes, which drops this an additional 10.2 volts or so. So that's actually drops this about 10.8 volts maybe, but we're still getting about 27 volts on the input of this voltage regulator, and it's on a 5-volt output, so it's quite a large voltage drop across this input and output. It's quite a big spread, and this thing gets quite hot. They have 2 outputs, 5VX and 5 volts, and they're a little bit different. One's a little bit lower than the other, like 0.6 of a volt. I was thinking of adding capacitors here on the input and output, because there really is none, and it probably would benefit it to have some. I don't know if that's how the noise is getting in or not. Here's the mains power supply. AC power comes in through this connector, goes through this switch. There's a back panel switch, goes through the fuse, and then there is a 220 nanofarad across the line X-rated cap, and then it goes to the mains transformer. This is a common mode choke, and this continues on down to the bridge rectifier to the switch mode power supply. So this common mode choke is kind of like acting like a barrier between the noise from here and the noise from the line. And anything that comes in can go straight through to the transformer. I'm thinking I'm going to pull this 220 nanofarad cap and check it, make sure it's good, because these can change in value, right, over time. And since it's completely turned on and switched on and on the line all the time, it could be taking hits. Even when the unit's powered off, it could be taking power surges and hits all the time, and this could be damaged. So that could be another possibility. Here's the controller chip. It's at Mega 48, and it's a small little surface mount chip. It's got multiple power sources, plus 5 volts, 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 plus 5 volts. And some of these have 100 nanofarad capacitors, and some don't. This one shows electrolytic, but it's labeled as 100 nanofarad. So I don't know what's going on with that. Power down. Oh, that would be a logic signal. Okay. That's not power there. This one's power. It goes straight in, and that's bypassed the ground. So we might be able to maybe bypass that with more capacitance to maybe clean that up. We got another 5 volts straight in shot here, and it has a 47 microfarad capacitor to ground. I remember checking some capacitors on the main on the front panel board, and they were okay. This one's bypassed with 100 nanofarad, so that one should be clean. I'm just trying to think of any room for improvement here with regards to cleaning up the power for this at Mega. If it's getting glitched from power surges, then we need to fix it. This one's not relevant. That's for thermal protection. So there's thermal protection coming in here, and that switches a line high or low depending on the thermal sensor. Power down. And we have 3 lines here going out, clock, data, and strobe. And that goes to these 2 chips. Let me see if I can bring those up. These are just Jelly Bean logic. They're 4094 and 4094B. And what they do is they run the LEDs according to what the controller wants. And this one here does the tone defeat. The front panel LED, blue, amber, and red. Volume control up and down. These 2 lines run the volume control motor, and then the tone defeat. And then, yeah, so this is just controlling the amplifier according to what the microprocessor wants. This one is just illuminates the correct LED for what mode it's in. So for right now, I think I'm going to do those 3 things. I'm going to take this power supply board out. I'm going to check this line cap. I am going to add bypass capacitors on the input and output of this voltage regulator. And I am going to go to the microprocessor and see if I can add some more bypass capacitors around where the power is feeding in, and just see if I can clean this up. And then that's pretty much all I can do for it, especially when you don't find a fault. There is no faults here. Everything is going strong. It sure does get hot though. What are we consuming right now? 36.5 watts sitting at idle doing nothing, which is fairly high, but not that high, I guess. So let's let me get started on that. All right, here's a look at the schematic for the thermal protect circuit. We have a little transistor. This comes from the thermal sensor, I believe, plus 5 volts. And there's a silicon diode going to the base. And then they have this capacitor C528. It's in red and it's got asterisks on it. 10 microfarad at 50 volts. Let's look what they say about that capacitor at the bottom. And they say right here, one must be added C528 to correct false protect if not installed. So that's a factory mod to help this circuit from false triggering. Now I don't think this is the part of the problem, because it's not going into protect. What it's doing is it's glitching and it's going into different modes. It's going into switching input functions and stuff. So I don't think that's it. Let's go have a look at the board at what this area is right here, and we'll have a look at that. Okay, here's the board. Here's D512, this little silicon diode here. And here's Q513. And they do have a capacitor here already. It is across both legs of this transistor. You can see it's on the other side of the board here. If I pull it out, you can see it. It's right here. And that is a 10 microfarad 50 volts. I think this is the one they're talking about. Now, if somebody came along here and tacked this on here, this is a 10 microfarad at 35 volts. And let's have a look at this. It's not even soldered down. The wire is loose. So that was ineffective. So I'll solder that back down. I don't think that's even the correct mod. I think they already have their capacitor in here. So what I'm also looking at is some of these bypass capacitors here are on this chip. If I don't think any of them failed, but just wondering if they're adequate. So I'm going to re-tack this thing down and secure it, and then we'll see what we can do here. There we go. Now it's properly secured. Okay, that's about as far as I'm going to take this thing today. Really can't do much for it. If I can't replicate the fault, I can't fix the fault, right? So, like I said at the beginning, this thing was behaving for 2 weeks before I opened it up and had a look. So, don't know if anything I did is going to make any difference. What I'm going to do is put this back on the shelf. And what I'm going to do first is I'm going to do a bias adjustment, make sure that's all good. And then I'm going to put it back on the desk and have a good listen to it and see if anything's changed. Now I did do some work. I know I did replaced a bunch of caps. These caps here, there's a small amount of these blue capacitors that were high ESR. They got replaced. That wasn't part of the problem. It was a side problem. But yeah, I'm just going to let this play out and see how it behaves. And if it needs to come back on the bench, it comes back. If it doesn't, it doesn't. That's the way it is. All right, so thanks for watching, and we'll see you on the next one. Take care.